Hello folks, let's continue with our 30th problem, which is already there on the board, which says that I is sin x dx over 1 plus cos x. As the form question is structured, it's very clear to us that the denominator is very easily going to give you the derivative. Its derivative is going to be the numerator. So maybe right away, let's start with the substitution here as u equal to 1 plus cos x. If you take the derivative over here, du over dx, derivative of 1 is not there. For cos x, the derivative is minus sin x. When we keep an eye on the numerator, it is sin x dx. So therefore, it's going to be minus du, which is going to make it as sin x dx. Quickly reverting back, you get I as negative du over u. So the negative sign outside, du over u, we all know is log modulus u plus c. So that way it is negative log modulus 1 plus cos x plus c. You can call this as the exponent and then write it in the denominator. That is also another equivalent form of writing the answer. We have the next problem very much like this problem. It says that it is sin x over 1 plus cos x the whole square. Very, very similar. Yeah, exactly on the same lines. So let's move exactly as we moved over here and let's try to see how the derivatives are going to come up like. So here it's going to be, as we did here, u to be 1 plus cos x. So you get du, negative du as sin x dx. Yeah, I can brief it up because it's already there over here. So you've got the I now becoming integral of negative du, minus is the outside, over u squared, or rather minus du times u raised to minus 2. When you take the integral, minus 2 plus 1 is minus 1 plus c. So it's just u raised to minus 1, which means it is 1 over 1 plus cos x plus c. It's only that much. Yeah, 1 over 1 plus cos x plus c. Okay, then we can quickly go to the next problem. I is equal to integral of dx over 1 plus cot x. As such, 1 plus cot x is not of much help to us. So we will try to write it as cos x over sin x. Again, keeping it this way is of no good. So let's try to equalize. So we will be getting this as integral of dx over sin x plus cos x sin x, or rather integral dx sin x plus cos x over sin x. See, here division by a fraction is multiplication by its reciprocal. By that, this will become sin x dx over sin x plus cos x. We are in a fix because the denominator is not going to help you get the numerator, nor the numerator is going to help you get the denominator. So there is no as such substitution which is going to work. So there has to be some mathematical manipulation which has to be used for you to get the answer. The manipulation that we're going to use here is, we are going to write this as half times 2 sin x. Now let's see how that is going to help us. 2 sin x actually can be always written as sin x plus cos x plus sin x minus cos x. Just see that when you expand, you will get 2 sin x. Yeah, but we have written it slightly, something that will help us. So since these two terms have got this common denominator, sin x plus cos x, let's treat them separately. Sin x plus cos x over sin x plus cos x, first term. Next term, sin x minus cos x over sin x plus cos x. What's the advantage? The advantage is that you get it simplified. So how are you going to get it simplified? Let's check that. So you're getting half times, first part of the integral is just dx because it is cancelling each other. And the next part, it is sin x minus cos x over sin x plus cos x dx. Let us try substituting u as sin x plus cos x. What will happen? Derivative will be, for sin x it's cos x, and for cos x it's minus sin x. So it is as good as saying, suppose if we multiply a minus sign on both sides. So what will happen? You are going to get minus cos x, and this is sin x. So that's exactly our numerator. A little bit of, so minus du is going to be your numerator now. So let's revert back. Half integral dx minus and minus, this can become plus, okay, because already minus, sorry, it will be minus because that du minus will come here, and denominator is u because you've taken this as u. That's all. So half times the integral dx is x, and this is going to be log modulus u plus c. So half times x minus log modulus u is what? It's sin x plus cos x plus c. That's about it. So that's going to be your answer, and this is how you go about doing this problem. Very tricky, and lots of adjustments done in order to get the answer. It is also occurring later on in the chapter where we use definite integrals. There also we do use it. There we use a different method. So that's all for this problem here. With more problems, let's meet in the next video. As I always tell, please popularize the channel and spread a word. Thank you.